But let us focus now on this equation approach. And the first step in studying everything is going to be studying all the things, all the curves given by all possible equations. Okay, so that's the first idea to keep in mind. Let us look at all the possible curves, and among all the possible curves, let's think about the simplest curves described by the simplest equations. And the simplest for calculus purposes is going to be linear. Now, what does it mean for an equation to be linear?
One variable is in terms of the other variable.
One variable is in terms of the other variable, like y equals x squared. Is that linear? Why not?
It's a parabola.
It's a parabola. What do we mean by linear?
It's 1 degree.
Well, algebraically, speaking of equations, it means degree 1. And if you have equation on two variables, it means both should be in degree 1. And of course, we allow coefficients. And that means something like a coefficient, a constant times x, plus a constant times y, plus maybe another constant equals 0, is the most general equation of a linear curve, a linear equation. And that is what our best equation is going to be for some time. Any curve described by this kind of equation is going to be the easiest. And we will study everything about this equation. We will have to understand every single constant and its meaning in this equation. And I'm not going to reduce that to the equation y equals mx plus b. First of all, because you know already what it means to have m and b in that equation. And second, that this approach will give us more geometry than y equals mx plus b, in some sense, a different geometry. And then the next step would be what? Once we study all linear curves, once we understand in detail what those numbers mean, what do we do next? How do we expand? Because there are different ways to expand. What would be the algebra way to expand? A possible algebra way to expand. To be more general, to study more curves. What is the next complication after degree 1? Degree 2, everybody knows that, right? Go quadratic, study parabolas. And then degree 3, go cubic. And degree 4, and so on. And this is not the calculus approach. Okay? We will go to what? We don't go by degree, as algebraists do. Calculus does what?
Linearization.
Linearization. Anything that can be linearized. Anything that can possibly be linearized is just the next step. And if you can linearize something, that means you can reduce the study to the study of linear curves using differentiation. And then that's the end of calculus. If something is not linearizable, we just don't look at it. And there are examples, of course. And the typical example is y equals absolute value of x. That has this corner, and that corner, of course, remains corner as you zoom in, no matter how close you zoom in.